Thank you all for joining. My name is Susan McGregor, and as mentioned, I am an associate research scholar at the Data Science Institute at Columbia University. I'm also the author of a recent O'Reilly volume called Practical Python, Data Wrangling and Data Quality. And today I thought I would do something might be a little bit different, which is talking about a specific part of data quality that I call data fitness. So just a little bit about me. This is the book that I wrote recently with O'Reilly. I've been using data to generate insights for over 15 years. I've been working with Python for over 10 years. Before I came to Columbia University, I worked primarily as a professional programmer, and essentially what we would now call as a data scientist. So I have a background in computer science, journalism, education, etc. And at the end of sort of my first decade of doing this, it seemed like a really great opportunity to synthesize everything that I had been working on into a book like the one that you see here, which I have to say has been nice because I realize now that looking back on it, I actually have documentation of a lot of things that I do, and I find it super useful. You can actually find all of the exercises and sample data sets from this book on GitHub under the Practical Python Data Wrangling and Data Quality title. So you should feel free to check that out if you want examples of any of the things that we're discussing. But today, I want to talk about something that feels a little bit more conceptual, which is about data quality. And I think for a lot of us who work with data on a regular basis, I know that the kinds of things that I think about when I look at a data set or data sets, there are some sort of more tangible aspects to it that have to do with, how it's structured, how complete it is, all kinds of things. But for me, data fitness actually has more to do with the question that we're trying to answer. And I think this is really important because I think as most of us are experiencing, the more and more data that's out there, the more important it is to assess its quality, right? There's a lot of bad data out there. And going back to kind of the old computer science axiom, garbage in, garbage out. No matter what you are trying to do, if you're trying to generate insights with data, if the data that you're using is poor quality, your insights and results are going to be poor quality too. So as I said, to me, I sort of think about data quality as having sort of two sides or principal components. And the first is data integrity. And when I think about data integrity, I'm thinking about all of the things you see listed here. So I'm thinking about provenance. Where did it come from? Who compiled it? Who collated it? What kind of documentation is available? I think is obviously really, really important. Anyone who's ever tried to decipher an API without good documentation knows what it means to live without it. And it's a pretty unpleasant situation. Most of the time when we're trying to generate insights, unless you're taking a strictly sort of historical and scholarly approach, most of the time you care about whether it's timely, right? How recent is it? Is it complete? Is there data missing? High volume, right? Most of us feel like, it's easier to do stuff with more data. Is it multivariate? Does it have a number of different measures or parameters, right, that we can use to try to generate insights or model a certain phenomenon? Is it atomic? So of course, it's much better for us to have data available that describes sort of granular, describes things in a granular way as opposed to summary statistics, right? Averages, medians, things like that are not going to be as useful for generating my own insights as something that is atomic and has kind of direct measures is going to be. Is it consistent? Really tricky thing that I've run into a lot, especially working with public data, is when measurements change over time. So a definitional term changes and suddenly a number or a parameter that has the same name actually represents a different measure or quantity. Is it clear? Can I understand what's going on? And is it dimensionally structured? So that's going to be, thinking about how the different parameters relate to one another. So again, to me, these are all characteristics of sort of the data, what I think of as sort of the data set itself, right? These are things that we can usually evaluate by looking at the data itself, like looking at it directly, maybe some metadata and documentation. But most of the time we can figure this out just with the data set itself. What I'm more interested in today is what I like to call data fitness. And the reason why I use the term fitness is I think of this as fitness for purpose, as in, does this let me do the thing that I want to do? And a lot of these concepts come out of sort of scientific approaches, statistical approaches. But to me, these really get at the heart of why we're using data in the first place, right? Most of the time when we're using data, it's because we want to be able to scale our level of insight. We want to be able to model something. We want to be able to predict something. And the thing with that is that if we don't have appropriate data fit, we will end up modeling something. We will end up predicting something. But is it really the thing that we're trying to model or predict? And this is where questions of data fitness come in. So the three characteristics that I think are most essential to data fitness are validity, reliability, and representativeness. And these are concepts that, as I mentioned, are used across science and statistics. And my hope today is to just sort of really quickly break these down for you all, and think about how these might, give you an opportunity to think about how these might apply to your own work. So again, when I say data fitness, what I mean is fitness for purpose. If I do my analyses properly, if I train my model correctly, can I actually do the thing that I want to do with this data? Does the data have the correct qualities to make that possible? So to me, the sort of three key, there's kind of three key examples of this, right? Will a model trained with this data accurately represent the real world situation that interests me, right? There's lots of different data out there that I could use to model different things, but is this going to be something that accurately that creates an accurate prediction or creates an accurate model? Will the data values be consistent over time, right? The data that I have might look good in and of itself, but do I have some sense of confidence that this is going to be applicable in a week, a day, a week, a month, a year, right? That's really important, because if I'm going to go to the time and trouble, for example, to train a model, I need to know, how frequently do I need to retrain this model to be sure that it's giving me what I need. And then I think, one thing that ends up tripping up, unfortunately, a lot of machine learning and other applications is, can I effectively apply my results to an entire population? And I think this is one that most of us are probably familiar with examples of this having gotten overlooked, and the outcomes are pretty negative. So just to sort of give an example, just to tie these two things together, validity is about whether the model is going to be accurate, or whether the analysis is going to generate accurate insights. Is this going to reflect how the world actually is, or is this going to be distorted in some way? Reliability, again, is, are they going to be consistent over time? If I come back to these data, or I perform these measures again, am I going to get something wildly different because of some factor or circumstance that I wasn't aware of when I started? And then representativeness is going to be that question of, can I effectively apply my results to an entire population, something beyond the particular set of data or the particular instances that are represented in my training data set. So I don't know if there's any XKCD fans here, but this is a sort of an old favorite of mine from XKCD. This is the sort of classic correlation causal inference mix-up. But it shows the problems that we get when we don't think appropriately about things like validity, reliability, and representativeness, right? Models, machine learning models, for the most part, they are generating associations, right? They are showing us the correlation between a set of factors and whatever our target predictor is. They're not telling us the substance of that relationship. They're not showing what causes what. And if we're not careful in thinking about what is going into the model in terms of training, then we can end up with some real validity problems, because things that we assume might have to do with the phenomenon that we want to predict might not actually predict it. And then you can get up into this situation where you have cancer causing cell phones. So there's actually two aspects to validity. And again, some of this, some of this language is probably familiar to many of you. There's kind of two aspects to that. There's construct validity, which is, does the data you have effectively capture the construct or the idea that you're trying to understand or model, right? So I think a really good way that I like to think about construct validity is anytime we try to build something that's supposed to tell us, identify the quote unquote best of something. Best is one of those tricky words that it seems like it should be obvious, and yet also obviously, anytime we're using data to try to model what is best, we have to think about how we're operationalizing best, right? In other words, what metrics, what measures, what parameters are we trying to optimize on in saying that something is best? So I like to use an example of schools. If you want to know what the best schools are in your area, well, what do you mean by best? Do you mean that the best for you, does the best school have the highest graduation rate? Does it have the highest test scores? Does it have the highest percentage of students going on to a four-year college, right? All of these are different measures, and depending on whom you talk to, they might say that one or the other of those is the best. Or is what is most important in deciding what is best. So when we think about construct validity, I like to think of that because a lot of times when we say something like quote unquote best, right, we sort of leave that there as though it's an effective or comprehensive descriptor, and it's really not. It really needs to be broken down much, much further to say, well, when we say best, we mean combination of graduation rate, four-year matriculation, et cetera, et cetera. So, if we have a set of data and we're saying we're going to try to predict X, the question is the parameters that I'm using to operationalize that idea, do they actually connect to it, right? Or are they, this is always the risk, just proxies for other things? So when we're thinking about validity, it's like how well do the data parameters that we have available actually capture the construct, the idea that we're trying to embody with this predictor, with this model? And then content validity is kind of the other half of that, which is basically saying, is the data that we have complete with respect to the thing that we're trying to operationalize on? So let's say that I think that the best school in my area is actually the one where students are most satisfied. Well, if I only have partial data on student satisfaction, or maybe I have a lot of data on student satisfaction, the question is like, is that data, is it actually is it a good measure in the first place, right? Maybe I've clarified that for me, best means student satisfaction, but then there's this question of the measure that I have, whatever it is that maybe they take surveys every year, right? Is that actually a good measure of that? And so that requires, and all of these aspects of data fitness really require us to dig a lot deeper into the context around the data that we're using, understanding how it was generated, who generated it, what the measures really mean, in order to determine, whether it's valid, whether it's reliable, whether it is representative, and therefore whether it is fit for our purposes. So that's validity. And I think just because of the way the layout of this works, I'm going to kind of go through to the end here, and then I'll happily circle back on any questions or comments. So the second aspect of data fitness that I think is really important to think about is reliability. And reliability also has kind of two sub aspects. One is accuracy. How precise is the measurement that I have, right? Is it sufficiently precise to reflect the changes that I need to measure in order to make my model meaningful, right? Or in order to make my prediction meaningful. So an example that I like to use with reliability is something that I think many of us are very familiar with these days, which is taking one's temperature. Okay, so when we start to think about accuracy and stability, and you think about something like measuring temperature, I think this is to me a really great concrete example. So if you have little kids, as I do, right, and many of us over the last couple of years have spent a lot of time taking your temperature, we have this first question of how accurate is our given thermometer, right? There's all different kinds of thermometers out there. There's all different ways of measuring, body temperature. I can take a mercury thermometer and put it under someone's tongue. I can use a digital thermometer and put it in the armpit. I can use an infrared thermometer and apply it to the forehead or under the ear. And so already you can probably imagine, if you think of those different tools, right, they have different levels of precision. A mercury thermometer is probably not going to be super precise. I don't think I could even read it precisely. Whereas a digital thermometer or an infrared thermometer might be very precise. Okay, so that's one aspect of thinking about how the tools that are being used to measure the thing that we are looking at, the parameter values, how accurate are they? What is the precision? But then there's also, and to what extent do they reflect the truth, right? Like, there is a body temperature. What is it? Because if you use those 3 different methods, you're going to get 3 different results. And then there's the stability question. So certain types of measures are probably going to be more stable over time. Again, if you have a small child, you're probably going to get better stability with something like a split-second infrared thermometer than you are trying to get them to hold a mercury thermometer under their tongue, right? Because that measure just isn't going to be particularly stable. It requires a small child to hold their mouth closed for a minute or 2 at a time, which is, at least my kids, very, very difficult to do. So again, when we're thinking about reliability, what we're trying to understand, an extension of this is we're trying to understand in yet another way how meaningful an extension of our results can be, right? If we have data collected over time, and we can see the degree of variation, right? We can see how much it varies from one set of readings to the next, or maybe over the course of days or months or years, depending on the time frame that is meaningful for the data you're working with. We can hopefully start to get a sense of reliability. But even reliability requires often a degree of subject matter expertise, right? Talking to people who know about the phenomenon that we are trying to predict or model is going to be really helpful, because they're just going to know things about those measures that even as a data expert, if we're not also a subject matter expert, are going to be really, really hard to evaluate. And then the last aspect of this, which again, I think is on some levels very well understood and yet often overlooked when we're creating models, is just representativeness, right? Is the population you're targeting proportionally represented within your sample or your training data, at least on the measures that matter, right? So as we operationalize our construct, right, we think about how we're measuring the best schools. Are we measuring that for all the people to whom we want, or the whole population to which we want to apply our eventual model or predictor? And there's obviously lots and lots of examples of this not working out, of models being developed where the training data is just too homogeneous in one respect or another. And then you end up with a product that goes to market that doesn't work so great for often a lot of people, right? None of us want to be in that situation. And so what does that mean? It means that when we're thinking about representativeness, we need to find out things about the population that we're interested in. So if we're creating a model that we hope to apply to all, let's say, all English language learners in the United States, right? We need to make sure that we have a sense of who's in that pool, right? Who's in that population. And we need to, again, probably work with subject matter experts to understand from people who have been working with that population, the things that matter in language acquisition for the different communities that fall into that population, right? And even if we can't, in creating our model, we can't sample on everything, right? Because of course, if we had access to that entire population, we wouldn't even be creating a model in the first place, right? We would just be, drawing a sort of a descriptive statistical portrait of it. But by working with subject matter experts to understand what affects the outcome, what is likely to affect the outcome of your model, and ensuring that your training data or your sample data is balanced, is proportional and representative with respect to those characteristics before you get going, you're just going to ensure that the application of your model, of your prediction is going to be, truly effective, right? It's going to do the thing that you want it to do. It's going to present an honest picture of the world. And yes, it's more work, but at the end of the day, if it's a distorted image, if what you're getting is kind of a distortion of what's actually out there, you're going to be losing out on a lot of really valuable and important opportunities. So at this point is where a lot of folks say, well, what do we do about this, right? And so the thing about how, so the question is, how do we remediate a lack of data fitness? In other words, I have a data set. I really, I have to use it because it's, it's what I've got to work with and I've been asked to solve a problem, or I'm constrained by professional or other obligations. And as is often the answer in these discussions, the answer is sort of more data, but maybe not necessarily in the way that you might think. And maybe you would, in which case, kudos, you're already well on your way. The first thing is just to be honest with yourself, right? And not try to pretend that a data set that you have can answer a question it can't, right? We just have to recognize the limitations of the data. And in some cases, that's sort of enough, right? If we can clearly articulate the data's limitations and therefore the model's limitations, sometimes that's the best that we can do. A lot of times, again, depending on where your data is coming from, you can start to think about other measures that can complement, right? That can counterbalance what you have or intersect with the data that you have in order to give you a more complete picture of what's going on. So for validity, this is often a strategy, right? If it turns out that the data that I have doesn't really allow me to create an accurate portrait of the phenomenon that I want to investigate, or that I want to model, then I may be able to find other data sets that I can intersect with my data, and use to kind of sample, create a more robust sample. By intersecting the data I have with the data that has additional parameters, I just create a more robust data set. I create a richer data set. And within that new data, there may be parameters that have greater construct validity, that have greater content validity. So what I like about the validity question is it forces us to really kind of, as I said, get granular about what it is we're trying to model, what we're trying to discover. And it's often kind of it can be sort of a challenging conversation, whether you're doing something on your own and kind of, having to walk through this process yourself, or working with a team, right? And really kind of pressing your colleagues or a client to say, well, what do you really mean by this, right? What are you really interested in? I think as anyone who's worked as an engineer knows, that often the biggest challenge, right, is identifying requirements, right, getting requirements right. And that's what validity forces us to do. It forces us to make sure that we all understand the requirements of the predictive tool or the model being built and agree on what those requirements are and how they're going to be operationalized in our work. Reliability can be a bit trickier. I mean, one way to first of all, it can be trickier in the sense that sometimes we're just stuck with the reliabilities of the reliability of the measures that are available, right? If you have a lot of resources and kind of enthusiasm, sometimes you can get more reliable data by going out and collecting some data yourself. I've seen this actually with some crowdsourced efforts to kind of check the reliability or confirm or test the reliability of, say, government data sets, right? Is it actually being measured? Do the on-the-ground measurements reflect the way that they're being reported? Sometimes if there are reliability issues, you may be able to use sampling methods as a way to mitigate that by not using the data set's values directly. But this one, they can all be tricky in their own ways. But again, you don't want to end up with a model that you're going to use a year from now only to realize that actually it's become unreliable after 3 months. So again, as with all of these, sometimes just scoping the limitation of where and how the prediction or model can be applied is a really key strategy. And representativeness is a little bit the same. Now, again, in the best case scenario, you're going to realize, you're going to look at the representativeness of your data set and say, actually, this isn't up to snuff. We need to go get more data. We need to recruit more participants. We need to rethink how we're structuring this. That's not always possible, right? We all operate within constraints of time and money. And sometimes the only thing we can say is, does not apply past this certain point. One of my favorite examples is when we look at things, again, like the weight and height gain of children. Sure, you can do that, but if you take the model of a baby's weight gain, and you try to extrapolate that into adulthood, you're going to end up with a 600-pound 12-year-old, right? And that doesn't apply. So if we can't get additional data, then we still just have to be very clear about what the limits, what the applicable limits of the model or predictor are, and just say, look, we feel confident that this is going to apply to these populations or these subpopulations. The trick there is that it requires that you know or acknowledge what the population of your sample data is, and I think sometimes even that's something that gets overlooked. But that's just the thing that you say is like, this is as far as we can go, and if we want to be able to say something meaningful about populations that are beyond that scope, then we're going to need to go do some more data collection and analysis. So again, part of the reason why I wanted to introduce these topics in this venue is because I know that they're hard. And so I'm unfortunately not here to offer kind of great tools for expediting data collection or analysis or anything like that, but really to try to encourage all of us to think really deeply about these issues as we're doing our work. Because at the end of the day, I think we all want to be generating real insights about the world. And it's not going to happen if we don't take these considerations into our work. So that is all. Thank you so much for your time. And I can switch to the questions if there are any. Yeah, so to David asked about the accuracy and precision, two different things. Yeah, so I should be clear that when I'm talking about accuracy and precision, first of all, I'm not necessarily talking about them in the same way that you might talk about, I'm not talking about them specifically in the sort of like machine learning aspect, but yes, they are sort of different. I guess the issue that I'm trying to get at is, accuracy is like, how true is it to the phenomenon? And one aspect of that when we're thinking about measures is about granularity and is about precision, right? So I mean, I could be technically accurate and say, well, my temperature is between 90 and 100 degrees, but that range doesn't give me an accurate view of the thing that matters, right? Which is, do I have a fever or not, or does my child have a fever? So you're right, they're definitely not exactly the same. It has, but it's a tricky thing, as I often find, in articulating these differences, because we have a lot of term overloading when it comes to language, right? And so accuracy and precision, right, in like a machine learning context, have very particular meanings, and there aren't a lot of good additional words for kind of talking about the conceptual aspect of that. But you are right to bring that up. I would certainly be happy to share the slides. I don't know if the folks asking about Python and Java are still on the line. I mean, I can talk about that a little bit. I mean, Python is technically a scripting language. Java is like a typed language. As usual, it would probably be helpful if there's a specific thing that you are curious about, like how they can be used as tools, because there's a lot of differences between them. But I don't know if that was... Yeah. Have you had any experience of trying to find data to train a model and answer a question but not finding anything that fits? Yeah, all the time, Kirsty. That is like most of the time. So a lot of the space that I operate in, because I actually come from in part from a journalism background, right, is trying to answer a question and there's no data at all. And I think that this is actually where it's hard to overstate the importance of cultivating relationships with subject matter experts. There are so many, depending on the kinds of things that you're interested in, there are so many professionals out there. And this is particularly true when you're working, like I've worked a lot with government data. In my book, I do a deep dive on the Paycheck Protection Program, which was some of you may remember from sort of the 2020 to 2021 during the height of the COVID-19 pandemic. And there are just thousands of people out there whose entire job it is to collect data and be really knowledgeable about things that you couldn't even imagine, that I would never imagine someone was really knowledgeable in. So this is where like scholars and academics, government not really officials, government employees, right? Just have just reams of data. And if you start to, if there's a certain type of thing that you're interested in and you start to kind of reach out to people, you can get amazing results. And it's stuff that is, you're not going to find it in a web search. You're not going to find it in, an API, because a lot of it is collected by mandate. And unfortunately, it's very hard to surface that kind of thing. So I definitely recommend, if there's a particular set of things that you're interested, say you're interested in environmental data or financial data or whatever, right? Like try to identify individuals who have expertise in the thing that you want to find an answer to, that you're trying to model. And just reach out to them. I find that government employees in particular are extremely positive and extremely responsive, and can just really open up a whole new world of insight and analysis. It was really nice sharing this with you, and I look forward to future questions, and enjoy the rest of the afternoon.